According to this theory, acids are any chemical species that can donate protons, while bases are any chemical species that can accept protons.
Ah, I see. Rather than considering both hydrogen and hydroxide ions, they focused only on the hydrogen ion, which is also commonly known as proton.
Correct. Thus, proton donors are specifically called Bronsted Lowry acids, while the proton acceptors are called Bronsted Lowry bases. The theory also introduces the concept of the conjugate acid and conjugate base. The species formed after a Bronsted Lowry base accepts a proton is called a conjugate acid, whereas a species that is formed after a Bronsted Lowry acid has donated its proton is called a conjugate base.
Whoa, now I'm really confused.
Don't worry, we're only going to scratch the surface of the theory at this level. You'll learn more about it in detail in A levels. So, for now, just focus on identifying the Bronsted Lowry acid and bases and their conjugate bases and acids respectively.
Aye, aye, Captain.
Good. Take an example of hydrochloric acid and water. Here we see that a hydrogen ion is transferred from the HCl molecule to the H2O molecule to make chloride ions and hydronium ions.
I see. As the hydrogen ion donor, HCl acts as a Bronsted Lowry acid. The chloride ion formed afterward is the conjugate base of hydrochloric acid. And H2O, on the other hand, accepts the hydrogen ion, thus it acts as a Bronsted Lowry base. The hydronium ion formed afterward is the conjugate acid of water.
Correct. In terms of chemical structure, this means that any Bronsted Lowry acid must contain a hydrogen that can dissociate as H+.
I got it now. And in order to accept a proton, a Bronsted Lowry base must have at least one lone pair of electrons to form a new bond with a proton.
You're right again. Take ammonia, NH3, as an example.
So, teacher, the lone pair of electrons in nitrogen is what makes it able to form a new bond with the proton donated by a water molecule. Am I right?
Absolutely. Now, can you name the conjugate acid and base formed in this reaction?
Of course. The ammonium ion is the conjugate acid of the Bronsted Lowry base, ammonia, while the hydroxide ion is the conjugate base of the Bronsted Lowry acid, H2O.
Fantastic.
Thanks. By the way, teacher, I noticed something strange here. In reaction with the acid, the water molecule acts as a proton acceptor. But in reaction with ammonia, the water molecule acts as a proton donor.
You raise a good point. Water acts as a Bronsted Lowry base with acids, whereas it acts as a Bronsted Lowry acid with bases. Thus, water is amphoteric in nature.
Oh, so this means amphoteric species are those that can behave as both acid and bases depending on what it's reacting with.
Finding this helpful? We have additional learning resources to offer. For Cambridge IGCSE and ASA level subjects.
Isn't hydrocyanic acid one of the weak acids?
Well, it is. Can you name some other weak acids that you know?
I do know some of them, like ethanoic acid, methanoic acid, and hydrofluoric acid.
Good. And do you know why these acids are weak acids while acids like sulfuric acid, nitric acid, and hydrochloric acid are considered strong acids?
I think I do. Acids which dissociate completely into their ions in aqueous solution are said to be strong acids, while those which dissociate only partially in aqueous solution are said to be weak acids.
Exactly. Additionally, the dissociation of a strong acid is irreversible, while that of a weak acid is reversible. Thus, the dissociation of a weak acid is an equilibrium reaction. The same can be said for bases as well. Strong bases like potassium hydroxide and sodium hydroxide are fully ionized when dissolved in water, while weak bases like ammonia are partially ionized.
So the ions formed from the dissociation of weak acids recombine back to form acids, which is why very few hydrogen ions are formed in comparison to the strong acids.
Indeed, the weaker the acid, the lower is the extent of dissociation. That is to say, the position of the equilibrium lies more towards the left side of the reaction, and the concentration of hydrogen ions is also less.
Oh, since the strong acids are completely dissociated while the weak acids are not, the strong acids have way more hydrogen ions in aqueous solutions than the weak acids.
Yes, but do note that as soon as the hydrogen ions are formed, they quickly turn into hydronium ions. So when we say hydrogen ion concentration for simplicity, we're actually referring to the hydronium ion concentration.
Ah, noted. So does that mean that the value of pH is determined by the concentration of hydrogen ions in the solution?
Indeed, the pH value is inversely related to the concentration of hydrogen ions of a solution.
And is that why strong acid has lower pH value than weak acid?
Yes, and there are different methods to know the pH value of solutions.
Well, I know about the litmus paper, but as far as I know, it only determines whether a solution is acidic or alkaline.
That's why we have the universal indicator and pH meter to find the pH value.
Oh yeah, that rainbow-colored indicator.
Yep, the universal indicator is a mixture of dyes that changes its color depending on the pH of the test solution. In fact, it exhibits different colors at different pH values. They are either in a paper form or in solution. Either way, we can find the pH by comparing the color obtained with the colors in this pH scale.
The color from yellow to red shows acidic solution, blue to violet indicates alkali, and green color indicates neutral solution. The pH scale is quite colorful.
It sure is. So Divash, let's move on to the pH meter.
Oh, is it some high-tech device used to measure pH?
Well, kinda. It's not as fancy as the universal indicator, but it sure will give you the 90s vibe. Take a look.
Well, I don't know about the 90s vibe, but to me, it looks like one of those old-school game consoles.
For your information, the 90s were the era of these old-school game consoles. Anyway, it's quite simple to measure with the pH meter. All you have to do is to calibrate the pH meter with solutions of known pH. After that, we dip the electrode in the test solution and the pH value reading will be displayed on its screen.
Register now for free.